Okay, so for this problem, I want to look at 40D, which is one of these solving a trig equations. Um, and I'm picking the one that looks ugly, so this guy. Um, so let me write that over here so it's by itself. Notice the pi here implies that we're working in radians. So radians. So one of the things I'm going to do first, I'm going to just refer to this thing on the inside as theta, just to make it a little bit simpler. So 2 cos theta equals root 3. So if I divide by 2, cos theta is going to be root 3 over 2. And since it's a regular cos problem, a regular trig problem, that should have infinite solutions. So if I take a look at the unit circle here, cos theta is x over r, so that occurs in a couple of places. This would be root 3, radius would be 2. Make that a little bit bigger. And so we're looking for theta here, or theta here. So the thetas that we get in radians, this would be 1. So let's see, that'd be pi over 6 and negative pi over 6, or you could say 11 pi over 6 if you wanted to. So then I know that theta is going to equal pi over 6 plus 2 pi k, or it'll also be negative pi over 6 plus 2 pi k. So those are my solutions for theta. And remember that the idea is that if you call this whole angle theta, you go as far as you can with theta for the general solution, and then you switch it out for the x term instead. So if I take these two and I write them again, so I'll write them side by side here. So pi over 6 plus 2 pi k, and then over here the alternate one was negative pi over 6 plus 2 pi k. Now what I'm going to do is switch out the theta. This guy goes back to being 1/4 x minus pi equals pi over 6 plus 2 pi k. And then over here, the same deal. Theta turns into 1/4 x minus pi equals negative pi over 6 plus 2 pi k. And now we can work this out. So I'm going to multiply both sides by 4. X minus pi equals 4 pi over 6 plus 8 pi k. And then I'm going to add pi. So if I add pi, this turns into 10 pi over 6 plus 8 pi k. And then I'll simplify a little bit. This becomes 5 pi over 3 plus 8 pi k. And then this guy over here, if I multiply both sides by 4, I'll get negative 4 pi over 6 plus 2 pi k, and then I'm going to add pi to both sides, and I'll get 2 pi over 6 plus 2 pi k, and then I'll simplify a little bit, and I'll get pi over 3 plus, whoops, sorry, I forgot to multiply that by 4. So that's actually 8 pi k. So I get this set of solutions and this set of solutions where k is an integer. And then that's it. That's it. So hopefully that makes sense. And that's it. All right. Oh, no, wait. Actually, there is another part to the problem. The other part to the problem is the first 3 positive solutions. So if we plug in k equals 0, in this case, that'll give us our first set of positive solutions. So let's see, the smaller one is over here. So when I plug in k equals 0, we get pi equals 3. And then k equals 0 here gives us 5 pi over 3. And then if I plug in k equals 1 over here, that'll give me the next smallest solution. So it's 8 pi plus pi over 3. Let me do that over here. So that's going to be 24 pi over 3 plus another pi over 3. That'll be 25 pi over 3. That's 5. 25 pi over 3. So there are my first 3 positive solutions.